All right, Matthew, some of you are having issues with section 5.3, those last few problems on the homework. And I've noticed you've been hitting those buttons, the explanation buttons, and it still hasn't helped. So let me walk you through it real fast so you could finish your 4-day weekend or start your 4-day weekend here. All right, so check it out. This is question 10, so I'm going to work backwards through these last two because these are the two giving people issues. So every day, we look at the lottery here. Every day, Jorge buys a lottery ticket. Yes, it's not George, it's Jorge. Each ticket has a probability of 0.4 of winning a prize. All right. After 4 days, what's the probability that Jorge has won at least one prize? Underline that word, at least one. We're going to be seeing that a lot, right? We've talked about the complement. So when we're looking at the probability of winning at least one prize, remember what could happen. He could win one prize, or he could win two prizes, or three, or up to four, because he's doing this for 4 days. All right. So that kind of that's multiple things that we'd have to calculate. So let's simplify this. So whenever we see that phrase at least one, what we're going to use is we're going to use the complement. And basically, we're going to find the probability of him winning nothing because that's much easier to find. And once we do that, then we're going to do 1 minus that probability. And there's your answer. All right. Which is much faster than the alternative. All right. So here, when you click the explanation, it said, we're going to find the probability that George wins on none of the 4 days. All right. So George wins absolutely nothing. Okay, so one thing that's been confusing people that I've noticed, because it shows me what answers you've been putting in, is you've been leaving this as 0.4 times 0.4 times 0.4 times 0.4. But notice the probability of him winning a prize is 0.4. But if he wins nothing, what we're saying is that he loses. So you have to do 1 minus 0.4, the complement, right? Think of it like the opposite. So the opposite of a 40% chance winning would be a 60% chance losing, right? And so that's why each one of these outcomes is 60%, right? And because if he wins the first day, that has no impact on or no influence on him winning the second day or the third or the fourth. So these are independent events, right? Because they don't impact another. So because they're independent events, the rules tell us that you could just multiply the probability of each event. And so that's where they get this multiplication for them. And so instead of just multiplying it 4 times, because what if it was 24? You wouldn't want to do this 24 times. There's a shortcut. So you do 0.6 raised to the 4th power in your calculator. All right. You take that answer, right, which is 0.1296. And because we're doing the complement, we do 1 minus that. And there's our probability. So we got around an 87% chance of him winning at least one of the days of those 4 days, right? So there you have it. So hopefully that helps out with number 10. And then with number 9, we have a similar situation where we're going to have to use a complement because there's that word again, at least one. So in the explanation, again, just to bear down, same thing. Notice in this explanation, they do go ahead and tell you that you're going to use 1 minus 0.7. Why is that? Well, look what it said. The probability that a certain make of car will need repairs in the first 6 months is 0.7. All right. So the dealer sells 4 such cars. What's the probability of at least one of them will need repairs? So again, we're going to do 1 minus the probability of none of them needing repairs. So if there's a 0.7 chance of one of these needing repairs, then that means the complement of 0.7, right, would be 0.3. So we're going to be using 0.3 times 0.3 times 0.3 times 0.3 because we're going to look at the probability that none of them need repairs. So that's why they did 1 minus 0.7. But in your case, in the calculator, you're just going to jump directly to 0.3 raised to the fourth. And it's 4 because here we're looking at 4 cars, right? A dealer has 4 such cars. So if this was a dealer had 17 such cars, this would be a 17. All right. And so that's not your final answer, right? Because this is just the probability that none of the 4 cars will need repairs. But because the question was at least one, what we do is we do 1 minus this probability. That's what they do down here. So 1 minus that probability, boom. So there's a 99% chance, right, that at least one of those cars is going to need a repair. All right. So again, we used this idea of independence because just because one car needed a repair is not going to influence the probability, the chance of that next car needing a repair. All right. So this is what we've talked about in class, but again, I saw you guys were having trouble on these last two, and you were pressing the exclamation button. But I just want to help you with what this is explaining so that it makes sense in here. All right, mathletes, if you have more questions, you let me know. Hope you have a wonderful weekend. Peace out.